we can cause a sparingly soluble salt to precipitate out of solution if we mix two solutions together and the product of the concentration of the ions concerned exceeds the solubility product. In this video, I'm going to show you how we can work that out. So first of all, let's unwrap what I have just said. We're going to mix two solutions. In my example, solution 1 is going to contain, let's go with 50 centimeters cubed of 0.05 mole per decimeter cubed of silver nitrate. And my second solution, some slightly wonky test tubes here, or beakers. They'd be quite big test tubes, wouldn't they? 50.0 centimeters cubed of 0.010 mole per decimeter cubed of potassium bromate. So if I pour one into the other, the question is, with those volumes and concentrations, will silver bromate precipitate out? How do I know that that is going to precipitate out and not the potassium nitrate? I know because I have learnt my table of soluble ionic compounds, and generally speaking, all group 1 compounds and all nitrates are soluble. So if you haven't done that bit of work yet for A level, you need to go away and learn which salts are commonly soluble and which ionic salts are generally not. So, KSP for silver bromate is 6.0 times 10 to the minus 5 mole squared dm to the minus 6. So if I mix these two solutions together, solution 1 and solution 2, and the product, or the sum of the concentrations of silver ions and bromate ions exceeds my solubility product, I will get a precipitate. If it doesn't, I won't. Step 1, we need to know what the concentration of silver ions is in the mixture. So the number of moles of silver ions that we added is the concentration times the volume. The volume needs to be in decimeters cubed, so that's 0.05 times 50 centimeters cubed, 0.05 decimeters cubed, and that comes to 0.0025 mole. So that's the number of silver ions added from solution number 1. The concentration of silver ions in my mixture, though, concentration equals moles divided by volume. Well, I know the number of moles, 0.0025. And in this case, the volume is the total volume, i.e. the volume of the mixture. 50 centimeters cubed plus 50 centimeters cubed, so that's 0.1 decimeter cubed. So the concentration of silver ions in this mixture is 0.025 mole per decimeter cubed. I'm now going to do exactly the same for the number of bromate ions. So concentration of bromate ions in my mixture. Well, first of all, how many moles have I added? So number of moles equals concentration times volume in decimeters cubed. Concentration was 0.01 mole per decimeter cubed. And the volume again was 50 centimeters cubed, so that's 0.05 decimeters. And that comes to 0.000, lots of noughts here, moles. So the concentration in my mixture, mole divided by volume, 0.005 moles over the total volume, which was 0.1 decimeter cubed. So that comes out to be 0.005 mole per per decimeter cubed. So I know the concentration of silver ions and I know the concentration of bromate ions in my mixed solution. So now I need to work out the ion product, the product or the sum of the concentrations. So we do this in the same way as we would for KSP. So ion product is equal to the concentration of silver ions. And I'm not raising these to the power of anything because it's a 1-to-1 ratio. So what do I mean by that? Well, if I were very quickly to write out the equilibrium for this saturated solution for the sparingly soluble salt, it would be going to form silver ions and the bromate 5 ions. So that's a 1-to-1 ratio. Okay, now I can put my numbers in. So, making some space here. Concentration of silver ions was 0.025 and the concentration of bromate ions was 0.005, and you multiply those two together, it comes to 1.25 times 10 to the minus 4 moles squared dm to the minus 6. Now if I can remind you, KSP was 6.0 times 10 to the minus 5. Okay, so I have a higher concentration of silver and bromate ions in my mixture than KSP. So we will see a precipitate when I mix these two particular solutions together. So very quick recap. Step 1 was to work out the concentration of silver ions in the mixture. Step 2 was to work out the concentration of bromate ions in the mixture. And step 3 was to work out the ion product, the sum of the concentration of these two ions. And then finally, we could make our comparison. Is it more or less, lower or higher than KSP? Because that is what tells us whether we form a precipitate or not. If this has been useful, hit the subscribe button, the effortless way to support your studies. And by clicking the link in the blurb below, it will take you straight to the Crunch Chemistry School, where you'll find all the resources you need to get that A-star grade at A-level. Together we can do this.